today's lesson is all about how subtraction and division are related. Last year, you should have learned how addition and multiplication are related. Multiplication is just repeated addition, where you take a number and you add it over and over and over again. You add it a certain amount of times and to get an answer. So repeated addition looks like this. If I have 4 times 3, well, I would take 4 and I would add it 3 times. 4 plus 4 is 8. That's 1, 2. I'm going to add 4 one more time because I need to add it 3. 8 plus 4 is 12. That means 4 times 3 is 12. Well, it's the same thing with division and subtraction, where you can do repeated subtraction. Repeated subtraction is subtracting the same number again and again to find the answer to a division problem. So if we have 12 divided by 2, and we don't know what that is, like maybe we don't know our basic facts yet, we're still learning, well, what we would do is we would we would subtract 2 from 12 until we get to 0. So we don't know. When we're doing repeated subtraction to try to figure out the answer to a division problem, we don't know how many times to subtract the number we're dividing by. So all we know is that we need to get to 0. So we're going to subtract 12 minus 2 is 10. That's 1 time. 10 minus 2 is 8. That's 2 times. 8 minus 2 is 6. That's 3 times. 6 minus 2 is 4. That's 4 times. 4 minus 2 is 2. That's 5 times. And 2 minus 2 is 0. That's 6 times. So I can subtract 2 6 times. Because I started with 12 and I subtracted 2 until I got to 0. Well, I had to subtract 2 6 times. That means there are 6 groups of 2 in 12. I can take 2 away 6 times, which means there are 6 groups of 2 in 12. That means 12 divided by 2 equals 6. If I'm writing it on here, you're writing it on your paper. If you're just now going back to write, that means you have no idea why you're doing it. You're just copying it because it's on the board. And copying it because it's on the board does not help. You have to know why you're writing what you're writing, which means you should be writing with me. Okay. Once you're finished, go ahead and put that to the side. Get out your math book and open to page 141. Okay. So we're going to look at one other way to do repeated subtraction. You guys might have probably did this last year with addition, where you used a number line and you counted how many times you jumped or skipped or bounced or whatever. Well, you can do the same thing with division. So say we have 8 divided by 2, and we don't quite know our basic facts yet. Well, what we're going to do is we're going to start at 8 and we're going to count back 2. So if we start at 8 and we count back 2, what number do we get to? Colin?
4.
If we count back 2. Aaron? 6. 1, 2. If we count back 2 more, where do we go? Zadie? 4. 1, 2. If we count back 2 more, where do we go? Zari?
To the 2.
2. 1, 2. Now our goal with this repeated subtraction is to get to 0. So are we done yet? Colin?
No.
No. If we count back 2 more, where do we go? Colin?
0.
0. 1, 2. So now we count how many times we jumped or how many times we skipped, whatever. 1, 2, 3, 4. So again, that means that there are 4 groups of 2 in 8. 8 divided by 2 is 4. If we draw 8 counters, 1, 2, 3, 4, 5, 6, 7, 8, and we separated it into groups of 2. 1, 2, 3, 4. How many groups of 2 do we have? Class?
4.
4. So that means 8 divided by 2 is 4. Okay. Now let's go ahead and look at page 141. All we're doing today is figuring out how subtraction and division are related by doing repeated subtraction. So, go ahead and read the sentences under the title. Sorry, loud and slow.
You know that repeated addition can be used to multiply. Repeated subtraction can be used to divide.
Good. Now, what I want you to do is in your book, I want you to write the definition for repeated subtraction. So get out your anchor chart because the definition is right there. And find where you have room. You're going to have to write small and neat. Okay? So, repeated subtraction. You can't see it up here. It's on your anchor chart. Make sure that you are copying it exactly as it appears on your anchor chart. Repeated subtraction is subtracting the same number. Write small and neat. We're going to add a little bit. So again and again, I'm adding something here. After again and again, we're adding the words until you get to 0 because that's important. We're trying to get to 0. So we're subtracting the same number again and again until you get 0 to find the answer to a division problem. So you're copying it exactly from your anchor chart, except that you are adding the words until you get to 0, until you get 0, between again and again, and to find the answer. So the definition, because you need to know this, otherwise it may not make sense. And I know, even though I give these to you, you guys are not great at using your tools yet. You will be. So you need to have it in your book, because I have a feeling you will put this in your math folder and never look at it again, even though it will be super helpful if you did look at it. So repeated subtraction is subtracting the same number again and again until you get 0 to find the answer to a division problem. When you're done with that, go ahead and put your anchor chart underneath your book, and then get ready to look at example 1. Okay, everybody, finger or pencil on example 1. Read in your head while I read out loud. Don't worry about it right now. It's not super important right now, so wait, focus on where we are, and then you can get it later. Example 1 says, Wyatt is giving 15 colored pencils to 3 friends. How many colored pencils will each friend get? Okay, well, we know our question is, how many colored pencils will each friend get? The word that comes after how many or how much more, how much less, in this case is colored pencils. Whatever comes after how many or how much or those words is always the answer unit. Whatever word comes after how many or how much is the unit that your answer is in. Pay attention to that because some of you, there was a question about banjos and strings, and it said how many strings will each banjo need, but you said the answer was 20 banjos. But what word comes after how many in the sentence? How many strings will each banjo need? Carla?
Strings.
So what should the unit have been of your answer?
It should have been strings.
It should have been strings.
Banjos.
So whatever comes after how many or how much is going to be the unit your answer will be. It's also going to be at least one of the units that you will divide or multiply or whatever. If we keep going, we see the word will each friend get. Each tells us we are multiplying or dividing. Each tells us that we are multiplying or dividing. I hope that you are doing this with me and copying this in your book. I cannot say how many times, if you're just going back after and copying what's on the board while I'm talking about something completely different, that means you are not fully understanding what I'm saying. You have to do it as we go, because going back to just copy it later does not help you if you don't know what, because you don't know why you're copying it. So again, each means we are multiplying or dividing. If the question has the word each in it, it is not going to be addition or subtraction. Then we look, and after the word each, we have friend. That means friend is our other unit. So that means in this question, we're going to have a number representing colored pencils, and we're going to have a number representing friends, because colored pencils comes after how many, and friend comes after each. Whatever comes after how many is a unit in the problem and the unit for the answer. Whatever comes after each is the other unit. That means that's the other number. So let's reread the problem and find a number that represents colored pencils and a number that represents friends. Wyatt is giving 15 colored pencils to 3 friends. Well, I see that 15 represents the number of colored pencils, and 3 represents the number of friends. That means those are my 2 parts of my problem. Now remember, if I already know the total, that means I'm going to be dividing. If I just know the pieces that make up the total, that means I'm going to be multiplying. Well, I already know that Wyatt is giving 15 colored pencils. That's all he has. All he has is 15 colored pencils. Can he end up with more after giving some away? Zadie?
No.
No. So that means we have to be doing what? He's not going to end up with any more. He's not going to end up with with more than 15 colored pencils by giving them away. He's not going to end up with more than 3 friends by giving his colored pencils away. So what does that mean? Are we going to end up with a larger answer or a smaller answer than the 2 numbers that we have?
A smaller answer.
So what operation do we have to be doing?
Division.
Division. Now in division, just like subtraction, the larger number has to come first. Out of 15 and 3, 15 is larger. 3 is the other number. So that means our equation is 15 divided by 3. 15 is the number of colored pencils, CP for short because I can't fit the whole words. 3 is the number of friends. I'm just going to put an F. Our answer is going to be colored pencils that each friend gets. So now, another way to solve this. You may already know the answer because you know your basic facts and you know fact families say whatever the multiplication problem is, the division problem uses the same numbers, just backwards. But say you didn't. We're going to do repeated subtraction. So we're going to take our first number, and that's where we're going to start. And we're going to subtract 3 until we get to what number? When are we going to stop? When are we going to stop subtracting 3? Zari?
when you get all the way down to 0.
When we get to 0. So let's start. We start with our dividend and we subtract our divisor. 15 minus 3, we need to get away from counting back and just being able to quickly say that 15 minus 3 is 12. If you still need to count back or use your fingers, okay, but you need to get to where you can do it in your head quickly. Now, are we going to start with 15 again? No, because watch what happens if I start with 15 again. 12, 15 minus 3 is 12. 15 minus 3 is 12. 15 minus 3 is 12. Did I ever get to 0?
No.
So is this ever going to end if I tried to do it this way?
No.
No, never. So what this arrow means right here is that you take this answer and then you start again. And each time you're going to subtract 3. You are never going to subtract anything other than 3 when you get 15 minus 3. Anytime you're doing repeated subtraction, you're subtracting your divisor each time. Remember the pieces of a division problem. The largest number, the number at the beginning, is the dividend. It's also the biggest number. It's also the longest word. Dividend has 1, 2, 3, 4, 5, 6, 7, 8 letters. Divisor has 1, 2, 3, 4, 5, 6, 7 letters. Quotient might have 1, 2, 3, 4, 5, 6, 7, 8. 8. But just remember, the quotient is the answer. Sorry, I thought that would work. The quotient is the answer, but if you're trying to figure out which one goes first, the dividend or the divisor, well, dividend has 8 letters. That's more than the divisor. The dividend is the first number in a division sentence. It must be the biggest. So you start with your dividend and you subtract your divisor each time until you get to 0. So now 12 minus 3 is 9. We're going to take 9 and make it our new minuend. 9 minus 3 is 6 because we're subtracting our divisor each time. That answer is going to be our new minuend. We're going to subtract the divisor. 6 minus 3 is 3. We take that answer, we make it our new minuend. 3 minus 3, because we're subtracting the same divisor each time, is 0. Now we can stop. So we started with 15 and we subtracted 3 each time until we got to 0. Now we can stop. And now to figure out what the answer to 15 divided by 3 is, we're going to count. How many times did we subtract 3? Count with me. 1, 2,
3.
Wait for me to point to it. Helen is the only one counting with me, but there are 10 people in this classroom. Let's start again. 1, 2, 3, 4, 5. That means we subtracted 3 from 15 5 times, which means 15 divided by 3 is 5. So each friend will get 5 friends or 5 colored pencils? Michaela, 5 colored pencils. Because if the question is how many colored pencils will each friend get, would the answer 5 friends make sense? No. Okay, so that is repeated subtraction. We are taking our dividend, the first number of our division sentence. We are subtracting the divisor, the second number of a division sentence, until we get 0. Then we count how many times we subtracted. The number of times we subtracted is the quotient. Remember those pieces of a division problem. Okay, let's go ahead and move on to example 2. Helper. Finger, pencil, and example 2. Read in your head while I read it loud. We're going to read it once to find the question and what we're looking for. Then we're going to read it again to find the pieces of our problem. The students in Mr. Bantha's class are helping set up games for Family Fun Math Night. Each game can have 4 players. How many games will be needed for 12 people? So there's our question. How many games will be needed for 12 people. Well, where do we find the answer, the unit our answer and at least one piece of our problem will be? Where do we find the unit that our answer and at least one piece of our problem will be? Smith.
In the question.
Where in the question? I know I'm going to find all my units in the question, but where do I find the unit that our answer will be and at least one piece of our equation will be?
After how many?
After how many? And what word is that?
Games.
Games. So games will be our answer unit and at least one piece of our equation. Now, we don't have the word each in this question, but we did have each in the problem. So each always means what are we going to be doing? Each always means what are we going to be doing? Colin?
Subtracting or division.
Subtracting? Does each ever mean we're subtracting? Aaron?
No.
What does each mean?
It means you're multiplying or dividing.
I'm multiplying or dividing. You will not see each in a subtraction problem. Now, repeated subtraction is a way to do division, but we're not technically finding the answer to a subtraction problem when we're doing repeated subtraction. If we are doing repeated subtraction, we're finding the answer to a division problem. They're just related. But if the problem has each in it, we're going to be multiplying or dividing. Now, we see another unit in our question. We see 12 people. That means people will be our other unit, and we actually already know the important piece of information. Because we actually have a piece of our equation in the answer, 12 people. So we know we need 12 somewhere. Now let's reread this problem to see what our other number is. We know 12 people. People is our other unit. That means 12 people has to be part of our equation. But we still don't know the number that represents the number of games, which is our answer unit and has to be another unit in the problem. So let's find a number that represents games. The students in Mr. Oh, wait. I do these. So weird. Okay. Oh, wait. Sorry. We see. Let's just find the other number in our problem, because sometimes the students in Mr. Bantha's class are helping set up games for Family Fun Math Night. Each game can have 4 players. How many games will be needed for 12 people? Is there anywhere in our problem that tells us this many games? Is there any number in our problem that represents games? Carla?
Yes.
What number? Where is there a number that represents games?
It is in the sentence behind Fun Math Night. It will say each game had 4 players.
Does that say how many games? Does that say a number and games, Carla?
No.
No. So is there any number that represents the number of games in this problem? Kingston, head up. Scoot your chair in so that you can't put your head down. Is there, is there a number in this problem that represents games? Zadie?
No.
No, but there is a number that represents what?
How many people?
How many players or people? Because we know players are people who play games. So what has to be our other number in our equation? We have 12 people and what? Four. What?
Players.
4 players. So we have 12 people and 4 players. In division, sometimes you will have the same unit because players are people who play a game. So that means we need to take the total number of people, which is 12, and divide it by the number of players, or people, that can play each game. So, the pieces of our problem are the total people, which is 12. Let me write this a little bigger. I'll put it right here. 12 divided by 4 equals something. We have the total people at the family game night. We have the people per game. And our answer will be the games that we need. We need this many games. So in order for every single person to have a game to play, we have to have a certain number of games so that nobody gets left out. So we're going to take the total people, divide it by the number of people that can play each game to get the number of games. So we can skip count backward on a number line to find 12 divided by 4. That's what we did earlier with our number line. We skip counted backwards to find 8 divided by 2. So we're going to do the same thing first. So here, step 1, find 12. Notice how 12 is highlighted in green. So let's find 12 on the number line. Someone come up here and point to 12. It has to be somebody at school. Because Victoria, come and point to 12. Just use your finger. Does that help us? Does that 12 help us at all? Where are we trying to find 12? Anywhere on the page? What are we using? Loudly.
A number line.
So where are we finding 12?
On a number line.
Okay. Good. So we found 12. Thank you. Go ahead, come see. That was step 1. Now we're going to skip count backwards by 4. Notice how 4 is blue until 0 is reached. Notice how 0 is yellow. You don't have to write the colors, however you can if it'll help you. Yes.
4 is actually like a pinkish
Oh, okay.
color.
Just kidding. Pink. Sorry, 4 is pink, 0 is yellow. So we found 12, which is green. We'll see why in a minute. We have to skip count backward by 4. That means we're counting backwards 4 spaces, which is pink, until we get to 0. So we started at 12. We're going to skip count backward. 1, 2, 3, 4. So that means I'm at 8, which means 12 minus 4 is what? Aaron? 8. Now I have to, am I at 0 yet though, class?
No.
No, so I have to go again. I have to count backwards. 1, 2, 3, 4. That means I land on 4, which means 8 minus 4 is what, class?
4.
4. Am I at 0 yet?
No.
No, so I have to go again. 1, 2, 3, 4. That means I land on 0, which means 4 minus 4 is what, class?
4. 0.
Am I at 0?
Yes.
Yes.
Do I have to keep going backwards?
No.
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 Now, count the number of times 4 was subtracted. Number of times is blue. So let's count how many times we subtracted 4. 1, 2, 3. How many times did we subtract 4, class?
3.
3.
3.
So now the model shows that 12, ooh, I see that 12 is green. And I see that each of these boxes is pink. So what do you think, what number do you think goes in each of these boxes, Victoria? 4. So 12 minus 4 minus 4 minus 4 equals, and I have a box that's yellow. What goes in the yellow box? Michaela? 0. I have 0 here. I have 0 here. So I know 12 minus 4 minus 4 minus 4 is 0. 4 was subtracted 3 times. So that means 12 divided by 4 equals what, class?
3.
3. So how many games will they need for the family fun night? If there are 12 people, 4 players can play each game. How many games will they need, Smith?
3.
3. Okay, everybody with me? Sometimes the trickiest part of word problems is just figuring out what are my numbers. But all you have to do is figure out, okay, what's the question asking me for? What numbers are represented in the problem? Do I know the total? Or do I know the pieces that make up the total? If I already know the total, there's no way I can end up with more or less. There's no way I can end up with more than the numbers. That means I have to be doing division or subtracting. But if I see the word each, which one am I doing, division or subtraction? If I see the word each and I know the total, I can't end up with any more than either of my numbers, but I see the word each. What am I doing, Zari?
Dividing.
Dividing. Good. If we look at this problem, the students in Mr. Bantha's class are helping set up games for Family Fun Math Night. Each game can have 4 players. How many games will be needed for 12 people? Well, if I'm trying to figure out how many games are needed for 12 people, 4 people can play each game. Am I ever going to end up with more than 12 people? No, there's only 12 people coming. No matter what. In math problems, it's not like real life. Math problems are whatever it says is what's happening. In real life, well, somebody's going to bring a friend. But in a math problem, that's it. There's only 12 signed up, there's only 12 coming. Each game can only have 4 players. Are we going to end up with more than 4 players per game? No. So that means we can't end up with anything bigger than 12 people or 4 games. So that means we're going to be dividing because our answer is going to be smaller than 12 people. We're not going to end up with more than 12. Okay, everybody with me? Let's look at the guided practice. And then we're going to do one of the independent practice so I can show you how to show your work. Because the guided practice gives you the boxes. The independent practice doesn't. So I'm going to show you how to show your work. Okay, helper number 2, please sanitize. Okay, so the directions for number 1 and 2 say use repeated subtraction to divide. That means you must use repeated subtraction, not fact families or mental math or anything like that. You must use repeated subtraction anywhere it says use repeated subtraction to divide. So do not give me homework or independent practice where it says use repeated subtraction and all you have is the answer. I need to see the repeated subtraction. So number 1, we have 10 divided by 2 equals something. Aaron, I'm going to use repeated subtraction. So do I start with my dividend or my divisor? Remember, the dividend is the first problem in a subtraction in a division problem. The dividend is the first number in a division problem. The divisor is the second. So with repeated subtraction, do I start with my dividend or do I start with my divisor? I start with the dividend. And then I subtract what each time in repeated subtraction? Don't tell me 2. The what? The divisor. In this case, it is 2. When am I going to stop? When I get to 0. So 10 minus 2, Aaron? 8. Now what's my new minuend in my subtraction problem? Do I start with 10 again? No, otherwise I'd be getting 10 minus 2 equals 8 over and over and over again forever. So my answer, the difference from my first subtraction problem becomes the minuend of my second. Do I change what I'm subtracting? No, because it's the divisor each time. 8 minus 2 is, my difference becomes my minuend. 6 minus 2 is, my difference becomes my minuend. 4 minus the divisor 2 is, my difference becomes my minuend. 2 minus 2 is, do I keep going? No. Now what do I do? To find this answer, what do I do? I count how many times I subtracted. So 1, 2, 3, 4, 5. How many times did I subtract? Which means there are how many groups of 2 in 10? So 10 divided by 2 is? Very good. I want to see where you counted how many. Very good. Number 2, we have 12 divided by 3 equals something. Well, Smith, we need to use repeated subtraction. So where am I starting? Sorry, what's the problem?
I go to the bathroom.
Go, but you're going to miss out. You needed to go earlier this morning. You needed to ask me while we were doing daily precept. Because you're going to miss out. We can't wait for you. Okay, Smith, where do we start? Do we start with the dividend or the divisor?
The dividend.
Which is what?
12.
Good. And then we subtract what each time? The
divisor.
which is
3.
3. Are we going to change what we subtract? Are we going to change the
No.
number we subtract?
No.
No. The subtrahend will stay the same. The minuend is what changes. So Smith, 12 minus 3 is
9.
9. That difference becomes our new minuend. We're not changing our subtrahend. 9 minus 3 is
6.
that difference becomes our new minuend. Our subtrahend is not changing. 6 minus 3 is
3.
Can I stop right there?
No.
No. What do I have to stop at?
0.
So my difference becomes my new minuend. 3 minus 3 is?
0.
Do I keep going? 0 minus 3?
No.
No. Okay, so now we've gotten to 0. Well, now how do we figure out our quotient? We have our dividend, our divisor. We need our quotient.
We count how many times we subtracted.
Good. So we subtracted 1. Count with me, Smith.
2, 3, 4.
How many times did we subtract?
4 times.
So there are how many groups of 3 in 12?
4.
Which means 12 divided by 3 is?
4.
Very good. Okay, let's go ahead and do number 3 in the independent practice together so that you can see how to set up your work. Helper number. So we're going to do number 4 together. Now this is how you're going to set up your work. You're going to set up your work exactly the same way the guided practice is, but you don't have any boxes. So number 4 is 14 divided by 2. Colin, where do we start? What part of our division problem do we start with?
With the dividend.
The dividend, which is
14.
14. And we're using repeated subtraction. We're not using fact families or basic facts. We're using repeated subtraction. So what does that mean we're doing next? We started with the dividend. Now we need to do what?
Subtract the divisor.
Subtract the divisor, which is
2.
2. Okay, and what does that equal? 14 minus 2 is?
12.
12. Now what? Do we start with our dividend again?
No.
No. What do we start with now?
All right.
What is this part of a subtraction problem called?
Quotient.
Can somebody help her out? What is this part of a subtraction problem called? Victoria. What? What is this part of a subtraction problem called? Aaron? The difference. So we start with the
Difference.
does our subtrahend change?
No.
Our subtrahend will be the same as what part of our division problem each time?
Dividend.
Not the dividend. The dividend's the first number. I'm not subtracting 14 each time.
The divisor.
The divisor. When can I stop subtracting 2?
Till we get to the 0.
When we get to the 0, okay? 12 minus 2 is?
10.
10 minus 2 is?
8.
8 minus 2 is?
6.
6 minus 2 is?
4.
Now you're going to have to write small. Those of you that write big, you're going to have to work on making your numbers small so that you can fit them all. Okay, 4 minus 2 is
2.
2 minus 2 is,
0.
do we keep going?
No.
Okay, now how do we figure out what the answer is?
We count how many times we subtracted.
We count how many times we subtracted. So count and I'll write the number.
1, 2, 3, 4, 5, 6, 7,
So how many groups of 2 are in 14?
7.
So that means 14 divided by 2 is
7.
7. I need to see this, your repeated subtraction. I need to see where you counted how many times you subtracted. So I need to see 14 minus 2 equals 12, 12 minus 2 equals 10, 10 minus 2 equals 8, 8 minus 2 equals 6, 6 minus 2 equals 4, 4 minus 2 equals 2, 2 minus 2 equals 0. And then I need to see where you counted 1, 2, 3, 4, 5, 6, 7. Make sure you have both of those parts and then of course the answer on the line. Go ahead and get out a separate sheet of paper because you are going to use a separate sheet of paper for both this and your homework. If you do it on the paper, you will lose points and you'll have to do it again so that I can read your answers. So get out a sheet of paper for your independent practice. You will also use a sheet of paper for your homework. Set it up the way I set up those papers for you before. So,
So we're not allowed to do it on the paper.
no, because then we can't read it, you can't read it, I can't read it. And some of you do have nice handwriting, but if I say if you need to do it on a separate sheet of paper, the people who need to do it on a separate sheet of paper are not going to listen. So that means everybody must do it on a separate sheet of paper. So, set it up. Number 3. And then 16 divided by 8 equals, and then show your subtraction and your counting. Then you can do a squiggly line or a line like I did, and then we already did number 4, so you can go to number 5. 18 divided by 6 equals, show your work, and then so on. Okay, go ahead and look at the back. Look at page 144. Everybody listen. Numbers 15, 16, and 17 are word problems. It is officially chapter 3. Everybody listen. I see people looking up here, not listening to what I'm saying. It is chapter 3, which officially means if you do not have the equation on the line, you lose a whole point. If you do not have the unit on the line after the answer, you lose a half point. If you do not show your work on the separate sheet of paper, you lose a whole point. It is officially chapter 3, which means I am looking for the equation, the answer, and the unit only. Only those 3 things on the lines for word problems. Make sure that you are paying attention to what the unit is, because starting in chapter 4, if you have the incorrect unit, you lose half a point. Because part of doing math is being able to read and solve word problems correctly. So, if you do not have the equation, the answer, and the unit on the line for word problems, you will lose a lot of points. Numbers 15 through 17 will be solved on your extra sheet of paper, not on the math book. You don't have enough room to show all of that repeated subtraction. Let's look at the homework. For numbers 1 through 9, you're doing the exact same thing as numbers 3 through 14 on the independent practice. You need to do it on a separate sheet of paper. Do not use the same sheet of paper for your independent practice and your homework, because they are 2 separate things. You need to keep them separate. Numbers 10 through 12 on the homework. Numbers 10 through 12 on the homework. I can already tell that some of you have tuned me out. Well, guess what? It's your own fault. Numbers 10 through 12, again, are word problems, just like numbers 15 through 17 on the independent practice. you need the equation, the answer, the unit on the line. Do not show your work on this homework page. Your work gets shown on your separate sheet of paper, just like this. You need all of these things for every single problem that you do. Number 12 on your homework, or number 13, I mean, you have to explain in words how to do this problem. Do not show the math. You have to explain in words. In words, what are you going to do? Do not show me there's this for number 13 on the homework, because that's not what it's asking you to do. It's asking you to explain it in words. Number 14, well, you don't have any work to show because you're looking at what they are showing. Does everybody understand? Because if you don't do this, you're telling me you understand because nobody's asking me questions about it. If you don't do this, then that means you're going to lose a lot of points. And if you don't do it on the independent practice, it means tomorrow during recess, you're going to have some math to do. Okay, what we're going to do now is go ahead. You should already have your sheet of paper for your independent practice. Put it in the independent practice pages because we're about to take our reading quiz. So put it away quickly. Put your anchor chart in your math folder. Put your math book away, your extra sheet of